Alright, we're going to look at linear models. And although one of the things we did do was create a linear model for the data, what we're going to ask you to do in this class is to look at a model and interpret the slope, the y-intercept, and the correlation coefficient. Okay, so fitting a line to data, most data is not perfectly linear. Okay, so if we have a situation like this, the vapor pressure of water depends on the temperature as shown below. So here's my temperature, and here is the pressure given. And we would create a scatter plot of that data. And the scatter plot for that data is right here. Here's a scatter plot for that data. You can see it certainly isn't linear. It has a kind of a curved pattern to it. Okay, but even when data has a curved pattern, often we're interested in a line that fits the data, and so we can use the equation that we get from that line and use it to make predictions, talk about how the variables are changing. Okay? And as I said, we've gone through how to get that equation, but we're not interested in that right now. All we're interested in is, can we do the interpretation? Here is the equation right here. So it's in y equals mx plus b format. And so the slope in this case is 2.2814. And the y-intercept is negative 16.971. Okay. And then r here, that is the correlation coefficient. You remember from when we talked about scatter plots before, correlation goes on a line from 0 to 1 to -1. Because everything correlation is how strong it is and whether it's positive or negative relationship. And this we can see has a positive relationship. As the temperature gets bigger, the pressure also gets bigger. And that's a positive correlation. Now if the graph was going downwards, then we would see that there was a negative correlation. Okay? If the correlation is close to 0, there's no correlation whatsoever. And this, anything close to here, is strong positive correlation. And anything over here is a strong negative correlation. And the closer the number gets to 0, the weaker the correlation is. So we have, maybe a moderately strong and then a weak positive. And we have a moderately strong negative and a weak negative. Okay? So our R in this case is 0.931. So one of the things we're going to do is interpret what that means. Okay, so we've got our line of best fit, or least squares line, regression line, trend line, given lots of different names. And they give us the slope of 2.2814. Remember, slope is rise over run. And the rise in this case will be 2.2814, and the run is going to be just 1. What that means is that for every one change, every unit change, we call it, when it's a change of 1, we call it a unit change. Every change of 1 in the run, which is the x variable, there's a change of 2.284 in the y variable. Okay? So we want to interpret the slope. It's done the same way every time. And we say this: for every increase of 1 degree Celsius in temperature, we don't need to write temperature because we wrote Celsius, okay, the pressure increases, or is predicted to increase. Sometimes you'll see is predicted to, sometimes they don't put that, to increase. Let me write that better. Is predicted to increase Now it could be decreased. If the slope was negative, it would be decreased by 2.2814. So much of this, you can see for every increase, and then is predicted to, this part could be decreased, but here is the x variable, and it always goes up by 1. Here is the y variable, and then here is the slope. And this one could be increase or decrease. If the slope is negative, then this is going to be decrease instead of increase. This right here could be decrease. Okay? That's how I do interpret the slope every single time. For every increase of 1, whatever it is, year, bushel, it doesn't matter. And interpret the y-intercept. Now the y-intercept, B, is negative 16.971. That's also done exactly the same way every time. Okay? And it's done like this. For a temperature of 0 degrees, the predicted or expected pressure is negative 16.971. Again, that would be the same way. It's always for whatever the 0 is, the predicted pressure is the y-intercept. Done exactly the same way every single time. Now you'll notice in this case, interpreting the y-intercept doesn't make a whole lot of sense because they give us a value at 0. Sometimes that happens with the y-intercept. It just doesn't make sense for us to interpret it, but we can always interpret the slope. All right, interpret the correlation coefficient R. R equals 0.931, which indicates a strong positive linear relationship between temperature and pressure, vapor pressure. That's it.